Good afternoon, everyone. Once again, I welcome you all on this 7 days workshop on time series analysis. And as we all know that we have experienced the past 3 days, we have learned a lot of things, lot of research areas, lots of formulas. And once again, I welcome Dr. Brijesh sir, our eminent resource person. Though he is not well today also, but sir's commitment is there. That's why he has joined on the time. So any query regarding preceding 3 days, you can ask to Brijesh sir before starting today's session. So any query you can ask to Dr. Brijesh, or we can start.
Very good evening, everyone. I hope you are very much clear with the yesterday topic, or we can say I am talking about the previous topic. Am I right or wrong?
Good evening. Good evening, sir.
Very good evening, Aditi ma'am. How are you?
I'm good, sir. How are you?
Not well. Not well. Okay, any doubt in previous topic?
No, sir. It was clear
It
yesterday.
is clear. Fantastic, fantastic. Anyone else? No. So I'm going to proceed further, and I'm just sharing my file with you. Just a minute. I'll open that file. That is what advertising. Right. And I'm sharing my screen. I hope it is visible to you all. Now, if I'm talking about basically, if you will see, when I'm talking about the assumption which is related to linear regression, the first is what linearity, and it is clear the mean of residual must be equals to 0 or up very close to 0, right? That is also we checked. If I'm talking about check the homoscedasticity, we already done yesterday, that how we will test the homoscedasticity. If you have remembered, with the help of residual and regression with residual, we can check that homoscedasticity. Then we will check the normality of error term, or we can say residual. We will do it today only. Then I'm talking about the autocorrelation of residual, then multi-collinearity. Right. Now, first of all, I'm going to discuss with you that is what multi-collinearity, and my data file is this. If you will see, we have 4 variables. Right. We have 4 variables. These variables are what? That is TV, radio, and newspaper. So I'm going to give advertisement in these 3 channels. That is what? Through TV, through radio, through newspaper. And my predicted variable is what? That is sales. Right. Now, question is this. Is there any correlation between the variable or not? Between the variable, that means among the independent variable. So how we will check it? We have a basic method to check it. I'm just doing it. I'm going to calculate the relationship between the variables, right? So how we will test it? You just look at here. Now, it is what data analysis, and the correlation, just click OK. Now I'm going to select my entire data. And because of I selected label in the first row, I select it. And if I'm talking about output, I'll take output on the same sheet. And where I'm going to take output, I will take output here only, right? And just click OK. So you will see this is what the correlation between the variables. Right. So if I'll ask the correlation between TV and TV is exactly 1. Why it's 1? Because of the correlation between the variable is same. And if I'm talking about the next, that is what TV and radio, the correlation between is 0.05, TV and newspaper 0 and 0.05, right? So we can easily find out the correlation among the independent variable. They remember this thing. What I'm looking for, I just share my file. Just a minute, I will close it and I will open the Word document. I will open the Word document, right? And you just try to understand what is the meaning of it. What I'm saying, the that is what multi-collinearity. If I'm talking about the multi-collinearity, suppose we have variable x1, variable x2, and variable x3, and this is what the variable y. Y is my dependent variable, and x is what my independent variable. Independent variable, independent variable. Definitely, there must be a linear relationship between the x and y. That means between the dependent variable and independent variable. There must be a linear regression. There must be a linear regression between the dependent variable and independent variable, right? Number 2, there should not be the relationship between x1 and x2, x2 and x3, or we can say x1 and x3. There should not be a relationship between these 3 variables. I hope it is clear to you all.
Yes, sir.
Right. So we require this relationship. There must be a linear relationship between the dependent variable and independent variable, but there should not be a relationship between the, that is what, independent variables. And how we will check that there is a relationship or not? If you have remember, we have TV, we have radio, and if I'm talking about my third variable, what is my third variable? That is newspaper. Right.
Newspaper.
That is what? Newspaper. And I'm talking about sales. So definitely, if I'm talking about the TV and sales, radio and sales, and newspaper and sales, there must be a relationship. Right. Now, if you will see the relationship between the sales with TV, sales with TV. So this is a perfect relationship, yes or no?
Yes, sir. 0.7.
And sales and radio, that is also good. But there is a weak relationship between the newspaper and sales. But okay, if I'm talking about the relationship between TV and radio, it is not good, right?
Yes, sir.
TV and newspaper, it is not good. But there is a relationship between newspaper and TV. So this is, it is a problematic.
Newspaper and radio.
Sorry, yes, radio and newspaper.
Yeah, sir.
There is a relationship between radio and newspaper. It's a problematic. Here, because of it's going to show you the relationship. So that is why we want to test the multi-collinearity. Although it's going to seem to me that there is a relationship between radio and newspaper, but this relationship is significant or not. This relationship is going to overlap or going to affect the sales. Suppose I'm going to give advertisement in what? Newspaper. I'm going to give advertisement in what? Radio. And definitely there is an increment in sale. Right. If you will look at here, I'm just going to stop sharing and I'm talking to you. Right. You just try to understand what I'm saying. I have given the invested or expenditure in radio, right? I have invested or expenditure in newspaper as well. What happened? My sales is increased. Yes or no?
Yes, sir.
Yes, sir.
What's the reason behind it? My sale is increased because of radio or because of newspaper?
Because of radio.
Why not newspaper?
Sir,
If you will see the if you have seen the correlation table, there is
Yes,
a
sir.
correlation between radio and newspaper. Yes or no?
Yes, sir.
That means if I'm going to invest in expenditure in radio, that means I'm also going to investing in the newspaper as well. Yes or no?
Yes, sir.
So
Yes,
that
sir.
is what there is a correlation between newspaper and radio. I want to know the impact. If I will remove the one variable, that is what radio. If I'll remove the one variable, that is what newspaper.
Newspaper.
Then I can find it out. Got your point?
Got it.
But in this case, when I am going to take all three variables, it is quite tough. That is why we have to test the multi-collinearity, right? Is it clear or
Yes,
not?
sir.
Just a minute, I will open the
Sir,
file
will you
again and
explain
share it
again, sir,
with
please?
you.
Sir, multi-collinearity, will you please explain it?
Just a minute, because of I don't know why my device is not working. It happens so many times, Anna. Actually my pointer is not working. Yes, now it's working. Wonderful, wonderful, wonderful. Yes, what was your question? Can you put on your camera so that we can interact? I will see who is asking this question. Yes, come on. Oh, when I asked you just put on your camera, nobody's asking question to me. That means there is no relationship between camera and question answer. Am I right?
This is Sandipti, sir,
Yeah.
from Karnataka. I
Yeah.
asked
Very good evening. Very good evening. Just ask your question, please.
sir, will you explain multi-collinearity again, sir? That is the
Definitely. I just share my screen with you, and you just look at here in this Word document. Can you see this image?
yes, sir.
Right.
Yes, sir.
I have three variables. That is what x1, yes or no, x2, and x3. These three are independent variable, right? And
Yes.
there is one dependent variable, that is what? Y. If I'm talking about the regression equation, what will be my regression equation?
A plus bxy,
Yes.
1 x b2 x2 and b3 x3.
This one?
Yes, sir.
Right. And what happened? There is one assumption that there must not be multi-collinearity between variables. Yes or no? There should not be multi-collinearity between the variable. What exactly we want? There must be a correlation between x1 and y. Yes or no? That
Yes,
is
sir.
why it's going to show you linearity. Similarly, there must be a relationship between x2 and y. There must be a linear relationship between x3 and y. Done? But there should not be correlation between the x1 and x2. Yes or no? There should not be correlation
Yes,
between
sir.
x1 and x2. There should not be correlation between x2 and x3. There should
Sir,
not
how
be correlation
how
between
we can identify?
how you can identify. Fantastic. Can you see this correlation table?
Yes, sir.
What do you think about this value? Is it a correlation between TV and radio? It is a
Yes, sir.
good correlation.
Very low.
In fact, almost zero, na?
Yes, sir.
What about TV and newspaper?
Is also zero, near about zero.
That means there is no correlation between TV and radio.
Radio.
There is no correlation between TV and newspaper.
Newspaper.
If I'm talking about radio and newspaper, what do you think about it?
Radio newspaper.
Yes, sir.
Right?
It's little bit.
Correlation is what? 0.3541.
Yes,
So
sir.
it's going to show you, yes, there is a moderate kind of correlation between radio and newspaper. It should not be there. Done?
Done, sir.
But can I consider it, or can I think, okay, let it go? It doesn't matter. It's not going to affect very much our regression model. Yes or no?
Yes, sir.
It is not going to affect our regression model. It is my perception. I'm thinking about it. Right? Now question is how we can test it. How we can test it. Have you heard that one term, that is what? VIF. That is what? Variance inflation factor. VIF is basically what? Variance inflation factor. Yes or no? Please note it down. There is
Sir,
one test that is known as VIF, variance inflation factor. We are going to calculate the variance inflation factor, and it's going to tell us if there is a significant effect or not on the multi-collinearity on the regression model. Yes or no?
Yes, sir.
And how we will test it? Just a minute, I'm going to show you. Now, if I'm talking about the formula of VIF is equals to 1 divided by 1 minus R square. What is R square?
Means of residual.
Sir.
R
Best fit.
square,
Model
R square
fit.
is the coefficient of determinant. Yes or no?
Yes, sir.
Okay. So this is the formula. Right? Now, what I'll do, how will I calculate? Because of we test the multi-collinearity between independent variable. Yes or no? We are not going to consider dependent variable, right?
Yes, sir.
Okay. So now I'm going to test it. How will I test? Look at here. Just VIF. I want to know, and VIF for what? I want to calculate for TV. I want to calculate for radio, and I want to calculate for newspaper. Agreed?
Yes, sir.
Now, what I am going to do, just go to the data tab, then go to the data analysis and come back to the regression. Got it? Okay. In regression, what you will choose? Input Y. This time I'm going to consider that my dependent variable is newspaper. Yes or no? Dependent variable is what? Newspaper. And my independent variables are what? TV and radio. Agreed? We have selected label. And where I want to get output, I want to get output on the same sheet here only. And done. And click OK. Got it? What is the value of R square? What is the value of R square?
126.
This is the value of R square.
Yes,
And
sir.
what is my dependent variable? Newspaper.
Yes, sir.
So newspaper was my dependent variable. Then what is the value of VIF? Equals to 1 divided by
1
1
minus
minus R
R
square,
R
square.
square.
bracket close and entered. What is the value come? 1.14519.
Yes, sir.
Okay.
Right. Okay. This is for newspaper. Now I'm talking about what? Radio. When I'm talking about radio, so radio is what my dependent variable now.
Yes, sir.
This
So
time, yes.
radio is my dependent variable. Okay.
So,
So what I'm going to do,
so first we take newspaper as a dependent variable, and next is radio for dependent
Yeah.
variable.
right. Actually, at this time, I took newspaper as a dependent variable and TV and radio as an independent variable, right?
Okay.
Next time, I will take a radio as a dependent variable, TV and newspaper as an independent variable. Third time, I will take TV as a dependent variable, radio and newspaper as an independent variable. I hope it is clear.
Yes, sir.
Right. Okay. So what I'll do, I'm going to Control C, Control X, and insert cell. Right. So this is what TV, radio, newspaper is my independent variable, and radio is my dependent variable. Done. And I'm going to again run the regression analysis. This regression, and because of I exchange the column now, and there is
Yes,
no
sir.
need to change in the input, right? If you will see, everything is perfect. Can you see when I click in input range, radio is my dependent variable?
Yes, sir.
Yes, sir.
When I click in X, right? So what happened? TV and newspaper is my dependent.
Dependent variable.
Independent variable. A label is
Yes, sir.
selected. Just click OK. And it's asking, okay, that the output is overlapping. Yes, definitely I want it. Just click OK. What is the value of R square?
0.12.
0.12. Just I'm
166.
going to take it here. This is for radio, right?
Yes, sir.
Yes,
Okay. Now, what I want to make it TV as a what?
Dependent.
variable? Right. And
Yes,
newspaper
sir.
is what?
Independent.
Independent.
Right. Again, what we have to do, we have to run regression.
Regression. Yes, sir.
Click OK. OK. And this, I will control. I will take the value here and I will calculate VIF. Done.
Yes, sir.
Okay. Now the value of output of VIF is what? 1.00.
Yes,
Yes
sir.
or no?
Yes, sir.
If I'm talking about radio, it is what? 1.14. If I'm talking about newspaper, that is also 1.145.
145.
Right?
Yes, sir.
Okay. Now, if I'm talking about,
Sir, excuse me, sir.
yeah,
Sir, can you let me know this calculation once again so that still it is not clear, sir.
okay,
For calculating.
I will repeat it again. Don't worry. Don't worry.
Okay, okay, sir. Thank you.
From which step you have doubt?
Sir, regarding R square, we have calculated second step, sir. 0.12 and 0.004.
Okay. About this. Okay,
Yes, sir, yes.
just a minute. I'll do it for you. What I'm going to do, a fantastic method, close, and what I'm going to do, don't save. Yes or no? This is the best way now,
Yes, sir. Yes, sir. Yes, sir.
so that nothing is there. Right? Up to this point, everything is clear.
Yes, sir.
Right. In fact, I'm going to delete it also.
Okay, sir.
Now, now I want to know the relationship between there's one value that is known as what? VIF. That is what?
Variance
Inflation factor.
inflation factor.
Right. I want to calculate it. And you have seen this value in so many research papers. Yes or no?
Yes, sir.
Right. And it's this test is for what? Multi-collinearity. This test is for multi-collinearity. And you just look at it, what I'm going to do. Just come to the data analysis. Then I'm going to select regression. I just click OK. And sales is my dependent variable, right?
Yes,
Yes,
sir.
sir.
And rest of the three variables are what? My
Independent.
Independent variables.
Right. Label is there. I want output here only on the same sheet. Done. Click OK. So this is what my data is ready. Right. Now what I want to calculate, I want to calculate IVF. VIF. I want to calculate VIF. Yes or no?
Yes, sir.
So it is written, yeah.
Right. Now, I want to calculate VIF for TV, VIF for radio, VIF for newspaper. Yes or no?
Yes,
Yes,
sir.
sir.
How will I calculate it?
As we done earlier.
The formula is what? VIF is equals to 1 divided by 1 minus
R
R
square.
Very simple formula. Right. Now, because of when we are talking about VIF, we will consider only what variables? Independent variable, right?
Okay, sir.
Remember this thing. And I'm calculating VIF for what? Newspaper. What? I'm going to calculate VIF for newspaper. How will I calculate? If I am calculating VIF for newspaper, VIF for newspaper, that means newspaper is my dependent variable. Yes or no?
Yes, sir.
And rest of the two variables, that is what? TV and radio
Sir,
is what? My independent variable.
sir, two variable, but we consider sales is dependent variable.
No, this is what my model. What is my point?
Yes, sir.
This is my model. This is my regression model. I am going to test in my regression model that there is a multi-collinearity or not.
Okay. Between independent variable.
Just try to understand what I want to say. I'm going to develop a model, regression model, and in that regression model, what I want to check? What I want to check?
Yeah, yeah.
I want to
Linear-
check that there is
Multi-
a multi-collinearity or not.
Yes,
Done.
sir. Done, sir.
Because of in our best fit model, we don't want that there must be a multi-collinearity. We don't
Okay.
want multi-collinearity in our model. I hope it is clear.
Okay,
Yes, sir.
sir.
Right. Now, what I'm going to do in this case, I'm talking about newspaper. So newspaper is what? My newspaper is my become dependent variable.
Dependent variable. Yes,
Right.
sir.
And TV and radio become my independent variable.
Okay, sir.
So again, I'm going to do a regression analysis, right?
Right, sir.
That is what data analysis, regression. Just tell me what is my dependent variable? Which one is my dependent variable?
Newspaper.
Newspaper is my dependent variable. I'm going to select newspaper, right?
Yes, sir.
Now I'm talking about input of X range. X is what? Independent?
Independent. Both
And which one is my independent variable?
TV and radio.
TV
TV.
and radio is my independent variable, right?
Yes, sir.
I
Right,
select
sir.
it.
Okay.
Labels, because of I selected. Where I want to get the output?
Same sheet.
Same sheet. I want to get output on same sheet, right?
Yes, sir.
This
Right.
place only. And just what should I do? Just click. Okay.
Okay.
Right. So you will get the value of R square. R square
sir.
when your newspaper is dependent variable, right?
Right, sir.
Yes,
This R
sir.
square value when your dependent variable is
Dependent.
newspaper,
Okay, sir.
right? And just this is what my value of R square, right? And I will take the value of R square. Done. Any doubt?
No, sir.
No, sir.
Right.
No, sir.
Okay. In the next time, when I'm talking about value of VIF, when radio, now radio is my
Dependent variable.
dependent
Dependent
variable. Yes
variable.
or no?
Yes,
Yes,
sir.
sir.
Radio is my dependent variable. So what I'm going to do is radio ko, can I take the left hand side?
Yes, sir. Huh.
Right.
Because-
So Control X and insert cut cell. Now radio become on this position na, in D column.
Yes, sir.
Yes, sir.
Basically, what I'm going to do, I'm going to save my time, right?
Yes, sir.
Because of I am not going to apply a formula every time. Yeah, now you just look at here. This is what data analysis, regression. If you will see, what is the input range? D1 to D201. Yes or no?
Yes,
Yes,
sir.
sir.
Yes.
D1 to D201. So D column is what my dependent variable now. That is what radio.
Yes, sir.
And if I'm talking about input range, that is what my independent variable. What is the value of independent variable? B1 to C201. B1
Yes,
to
TV and newspaper.
right. That means TV and newspaper, right? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Now just click OK. Because of the output is overwriting, that is why this warning is come. You just click OK. Got it? Now you will get the value of R square. Yes or no?
Yes,
This
Yes,
R
sir.
square is value
Yes.
for radio, right? Now I'm talking about TV. Now I'm talking about TV. So this time TV is become my dependent variable. And radio and newspaper is what my independent variable.
Independent variable.
Right. Okay. Can I shift TV left hand side, right hand side, or
Yes, sir.
let it go?
Let it go, sir.
Let it go. Okay. So in that case, I have to select the columns again. Yes or no?
Yes, sir.
Yes, sir.
So just delete my dependent variable is what? TV. Yes or no? And what about my independent variable?
Newspaper, radio.
Newspaper and radio. Just click OK and OK. You got the answer?
Yes, sir.
Right. What is the value of R square?
0.0049459.
Right. This is the value of R square. Now, what is the formula of VIF?
1/1 minus R square.
1 minus R
Equals
square.
to 1 divided by 1 minus
R
R
square.
square. Right?
Right, sir.
Yes.
Just entered. Can I drag it?
Yes, sir.
What we got? We got the value of VIF now.
Yes,
Yes,
sir.
sir.
I just cut and paste the same value so that I can delete the R
R
square
square.
column. I can delete the this. Now my sheet become normal now. So this
Yes,
is
sir.
the value of
VIF.
VIF. Right. Now we are not able to understand what's the meaning of these values. Yes or no?
Yes, sir.
Sir.
What's the meaning of 1.00? What's the meaning of 1.144? If you will see the strictly cutoff value is what? These value must be less than 3. These value must be less than 3. And in this case, our all values are less than 3.
Yes, sir.
Our all values are less than
Less than
3.
3.
Less than 3 shows what? There is no multi-collinearity between the independent variable. Gotten my point?
Yes, sir.
Although if you have remember, when we calculate the correlation, what was there?
Sir, can you repeat it? Pardon, sir.
Just a minute.
If the value VIF value is less than 3.
Just a minute.
Okay, sir.
If you will see, these two correlations are perfect.
Yes, sir.
Actually, there is no correlation now among the independent variable.
Yes, sir.
I'm not going
There
to
was-
consider
6.
sales. Yes or no?
Yes, sir.
Yes.
Because sales is my dependent variable. Sales is what? My dependent variable. I'm not going to consider it. But if you will see, these two values are, that means it's going to show there is no correlation between TV and newspaper, TV and radio. But it's going to show the slightly correlation between newspaper and TV.
Radio.
Oh, newspaper and radio. Newspaper and radio. So it become a problem for me, yes or no?
Yes, sir.
And I want to clear this problem, that there is a seriously a correlation, or we can consider it, okay, sir, we can take it in our model.
Yes.
So we want to test it. How we can test it? With the help of VIF, we can test it. So we got the value of VIF. Yes or no?
Yes, sir.
And all the value of VIF are less than
3.
all the value of VIF are less than 3. Less than 3 matlab it's going to tell us there is no multi-collinearity between the independent variable. Yes or no?
Yes, sir.
That means in this case, if you have remember, yesterday we did what? There is a linearity,
Yes, sir.
model fit.
Yes, sir.
Yes, sir.
All the independent variable are very well predicting the dependent variable.
Yes, sir.
All the p-value, these two p-values are what? Perfect. That
Perfect, sir.
means paper is not
Yes,
playing
sir.
a good role. We can eliminate it. We can
Yes, sir.
eliminate
Eliminate
it. In fact, when we check the multi-collinearity, what we found? That there is no multi-collinearity among our data set. Yes or no?
Yes, sir.
So up to this point, my analysis is perfect. My model is perfect. But there is only one thing. There is only one thing that we
I want to.
Yes, please.
Sir, I just want to know why we have compared it with the less than 3. Why not 1 or 1, 2 or
Because of the who developed this VIF model, who gave me this cutoff value, right?
So we can relate it with the laptop routers and multi-routers.
Yes, please.
Can we related its laptop routers?
Your voice
Laptop
is not
routers.
clear. Your voice is not
Oh,
clear. Just a
okay.
minute. Just a minute. Sometime it happens because of the camera. Okay, it takes lot of bytes now. Yes, now you can repeat.
Sir, can we relate to laptop routers? Yes or not?
Yeah, we can relate it. We
Okay.
can relate to leptoglossus. Basically, what happened? If you have remember, the statistician developed a fantastic model that is called p-value. Yes or no?
Yes, sir.
Yes, sir.
And with the help of p-value, we can easily analyze the hypothesis that we are going to accept it or we are going to reject it.
Okay.
Right. But in this case, we have the value of what? The limitation. That is what 3 means. When I'm going to talk about the strict BIF should be below 3.0. Yes or no? When I'm
Yes, sir.
talking about strict, that is must be no multi-collinearity. Right? When you become strict, if you want that little bit multi-collinearity ko chalne do, let it go. In that case, we will use less than 5. Okay, actually, it is totally depend on statisticians, what they think, how much they allowed, right? If I'm talking about
Sir, excuse me, sir.
how you will decide the this significance level. Can anybody explain? We always take 5% level as a significance level. How we can decide 5% as a significance level?
Just assumption.
No.
P-value is less than 0.05, then we
Yeah,
assume
why 0.05? Why not 0.04? Why not 0.035? Yes, come on. You will find there are so many research papers where significance level is 1%, that means 0.01. Yes or no?
Yes,
Yes,
sir.
sir.
In experimental
And
science.
there are so many papers where you will find significance level is 5%, 0.05. And in some very less, but in some research paper where you will find a significance level is 0.10, that is 10%. So it totally depends on what? The
Value.
intensity, the sensitivity of your hypothesis, right? I'll give you one example. Suppose I want to visit Agra. I'm at Jaipur. I want to visit Agra. Anybody from Agra? No. Okay.
No, sir.
Anybody?
Yes, sir. I am from Agra.
Oh, Dr. Raju, you are from Agra. Fantastic. So I'm coming to Agra and we are going to meet with you, right?
You are most welcome, sir.
Right. So
Please mention me the dates.
I'm coming Jaipur to Agra. The distance is around 300 kilometers.
Yeah.
So 300 one way, 300 returning. Total 600. If my car is going to give me 15 average of 15 kilometer per liter, in that case 600 divided by 15, that is what 40 liters petrol we required.
Yes, sir.
And the price of a petrol is 105.
Yes, sir.
Yes, sir.
That is what we required 4200.
Only for
We required 4200, or we can say we required 40 liter petrol. Yes or no? We
Yes, sir.
required 40 liter petrol.
Yes.
If suppose I will take only 35 liter petrol from Jaipur, and because of the tank capacity is 35 liter, I took 35 liter full tank. I come to the Agra and I'm coming back. suddenly I found that petrol is empty, my fuel tank is empty. Is there any problem with me?
Yes, sir.
Yes, sir.
No
No,
way,
sir.
not at all. Because of in every 2 or 5 kilometer, I will get a petrol pump. Yes or no? Even on
Yes, sir.
highways.
Yes,
Yes, sir.
So I will
Everywhere.
take a lift from someone. I will take a bottle. I will take a diesel or petrol from the filling station, and I come back and I will fill my tank. Yes or no?
Sir,
It
it's
is not
very
a very serious issue. Yes or no? But
Yes, sir.
I am going to launch a satellite on Mars.
Very serious issue.
According to my calculation, we require 35.4 liter petrol. 35.4. It is an example. Please don't quote, na? Okay, satellite requires this much of, spaceship required this much of petrol. Suppose the spaceship is required 34.5 liter petrol, and I filled 35 liter petrol. Is there a serious issue?
It is, sir.
Definitely.
Yes, sir.
Because of on which point my petrol must be empty so that my engine will stop. My engine will continuous running just because of half liter.
Yes, sir.
It might be my satellite, my spaceship will cross the orbit of Mars. Yes or no?
Yes, sir.
तो पता करा था कि मंगल ग्रह पे मैंने क्या छोड़ा था, सैटेलाइट. My satellite reached to Saturn. Problem हो गई ना? Yes or no? It's a
Yes, sir.
problematic
Yes,
issue or
sir.
not?
It's a complicated problem.
Big issue, sir.
So in that case, we have to maintain the accuracy. So my significance level what? 0.00001. That means almost 100% confidence level we required.
Okay.
Right?
yes,
Right,
sir.
sir.
And what in case of when I'm planning to visit Agra, I think 5% significance is sufficient now.
Sufficient.
Yes,
Yes,
sir.
sir.
In fact, 10% significance is also sufficient.
So it
Right.
depends on data.
Yeah, it's totally depend on hypothesis. What is your hypothesis?
Yes, sir.
So it is totally that is why you will get a p-value on the basis of 1%, on the basis of 5%, on the basis of, like Excel is going to give you the p-value on the basis of 5% in most of the cases. Yes or no?
Yes, sir.
Yes.
Right. But in case of this VIF, we are going to compare it what? 3. When I'm very much strict, no, there must not be collinearity. If I am so a little bit lenient, then I will consider it must be less than 5.
Fine.
And there are some person, they will consider it must be less than 10. It must be less than
10.
10. So it's totally depend on topic to topic, sensitivity to sensitivity, hypothesis to hypothesis, and researcher to researcher. There is no fixed line. I hope it is clear to everyone.
The
Yes, sir.
concept
Very
is
much clear, sir.
sir.
Good example.
Right. So,
Sir, excuse me, sir.
yeah, please.
Sir, if VIF for all the 3 variables is less than 3, if it crosses more than 5 for only one variable, then is it possible, sir?
In that case, you have to eliminate that variable.
We need to eliminate.
Yeah. Because of if you have remember in our case, when we calculate the correlation between the independent variable, you find there's a relationship between newspaper and radio.
Yes, sir.
Right. Both are working on the same intensity.
Yes, sir.
Definitely, whatever we are getting the response from radio, the same response we are getting from newspaper. So
Yes,
why
sir.
should I spend my amount on both media? It's better I will spend the amount on either newspaper or radio. Got it?
Yes, sir.
Yes or no, Sachinji?
Yes, sir. Yes, sir.
Right. Now, so it is all about
Sir,
what?
is it compulsory that we need to eliminate that variables? Means, can we reuse? Means, is there any thing that we can include by using some other tests?
Okay,
Or...
I'll give you one example. I'll give you one example. You are preparing one vegetable. Yes or no?
Yes, sir. Yes, sir.
I'll take a fantastic example. You are preparing vegetable and you want some, खट्टापन उसके अंदर आपको चाहिए.
Yes, sir.
What you will use? You have lemon, you have as well as tartaric acid, right?
Yes, sir. Yes, sir.
So what you will do? You are using both
Yes, sir.
and getting the same response.
Yes, sir.
It's better you will use either lemon or either tartaric acid. Yes or no?
Yes, sir.
Yes,
What's
sir.
what's the purpose of using both?
सर खट्टापन के लिए.
खट्टापन के लिए करते हैं सर.
तो एक चीज से भी मिल जाएगा ना. You will get the from the same thing.
Yes, sir.
हाँ इधर डबल खट्टा
नहीं, वो तो गड़बड़ करेगा ना. वही तो गड़बड़ कर रहा है क्योंकि दोनों का नेचर बिल्कुल सेम है ना. यदि दोनों को यूज कर दोगे तो क्या हो जाएगा? उसका इफेक्ट तो सेम आ रहा है ना.
Yes.
So we invest on the two commodities. We will invest on one. Right.
Yes.
So can we take a tuition from two tutors when
No, sir.
we are studying in 10th standard and both of that means you and me both of are weak in mathematics? Can we take tuition from two tutors for mathematics?
No, sir. No, sir. No, sir.
Kyun, what's the problem with it?
Again, it
Because
will
of
create
both,
confusion.
there is a correlation between both person, na?
Yes.
Both are giving the same. There is a direct relationship between tutor X is going to teach me. Definitely, the more time he invested, I will get more marks. Same with tutor 2.
Yes, sir.
But I found that both tutors are same. What is the purpose of it? I will approach to both tutor. I will take one tutor only.
Yes,
and
sir.
I will get the same result.
Yes, sir.
What is our purpose? That our dependent variable must be predict the future. Yes or no? हमारा
Yes, sir.
regression का purpose क्या है? So that we can predict the future in a better way with more accuracy. Right? Now I'll come back. So I hope it is clear. है ना? VIF. There is another thing that is what autocorrelation. What is autocorrelation? It was a multi-collinearity. Now I am talking about autocorrelation. What is autocorrelation? Yes, come on. If I have a series, I have a data. I want to check that there is a correlation between the same variable or not. I'll share one file with you. Is it visible?
Yes, sir.
Now, and this is what say I have a data that is sales, right? And the value is what? 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Right. What I'm going to do, I want to check the correlation among the same series, but different time. With different time. So what I'm going to do, I took a series. Control C and Control V. Right? Again, I am going to take this series. If you will see, I leave the first number and include the last number. In this series, I took the first number and leave the last number. Yes or no?
Yes, sir. Yes, sir. Yes.
Yes or
Yes,
no?
sir.
That means I am there is a lag of 1. There is a leg of one data. Yes or no?
Yes, sir.
I will consider this is X and this is Y. Now I want to calculate the correlation. Correlation this, comma, this. What is the correlation?
1.
1. Okay. Can I do one thing? I'll take leg of 2. I'll take equals to VOR. Correlation between this, comma, this. Now I will take another example where I will take leg of 2. Leg of 2. This is what X and this is Y. And here I'm talking about leg is equals to 2.
2.
And here I will find the correlation. So I'll take, I will leave last 2 values, right? Yes or no?
Yes, sir.
Yes, sir.
And this time I will leave first 2 values, right?
Okay, sir.
And I will calculate the correlation. What is the correlation?
1.
1. Right. Okay. What I'll do, I will take some random numbers, say 10, 12, 15, 18, 21, 23, 25, 29, 34, and 37. Done?
Yes, sir.
And now Control C, Control V, then Control C and Control V.
Okay.
What is the correlation?
0.99.
Less than 1.
994.
Right. And Control C, Control V, and Control C, Control V. What's the correlation?
0.98.
0.98.
Right. Can we take leg 2, leg 3?
Yes, sir.
Now, so 3.
Yes, sir.
Control V and 3. Control C and Control V. Now correlation. If you observe this thing, when I'm increasing the lag, the correlation is going down,
Down. Yes, sir.
right?
Right,
And
sir.
what we want, when I took the assumption, if I'm talking about the assumption of the linear regression, it says there should not be autocorrelation. There should not be autocorrelation in what? Residual. Yes or no? Because of in regression analysis, there are many independent variable and one dependent variable. That is why what we will do, we will talk about the residual. We will talk about the residual, that there should not be a autocorrelation in what? A residual. Agreed? And I told you how we can calculate the autocorrelation. I'll take some other example. Just a minute. I have some other example also. That is what autocorrelation. You can see it. Control C. It is visible.
Yes, sir.
Yes, sir.
Yes, sir.
Can we calculate autocorrelation for leg 1?
Yes, sir.
How will calculate?
Sir, why we choose leg 1?
No, you can choose leg 2 also.
Why? But why?
How you will find the correlation among the same series? If I'm talking about, I'm interested to find the, can you please put on the camera? Who is asking this question?
Yes, sir.
If I'm talking about the regression, if I'm talking about other series, how will I check that there is a correlation among the same series?
Okay, same series, between the same series.
Between the same series. If you have remember when I took the value 10, 20, 30, 40, 50, 60 up to 100.
Yes, sir.
There is an equal increment now.
Yes, sir.
So
Equal
you can
increment.
predict the value for n number of times. After 100, that means there must be 110, 120, 130, 140.
Yes, sir.
How you will predict it?
No, sir.
Because of there is a equal gap.
Equal gap. Yes,
But
sir.
is there a seriously equal gap? What
Yes, sir.
I'm going to do, I am going to divide the same series into 2 parts.
Okay.
I took the entire series, I'll just leave the last number. Then in second time, I took the entire series, but I left the first number. So we got the 2 series now from the same series.
Yes, sir. Same series.
Then I'm going to calculate the what?
Correlation.
Correlation.
Between same series.
Between the same series.
Yes, sir.
If there is a correlation, if there is a correlation, what is going to show me?
Correlation in the same series or other?
No. When I got the correlation between these two, when I use leg 1,
yes, sir.
I found that R is equals to 1. It's going to show me that there is a auto correlation between that series.
Okay.
When I took leg 2, even then it's going to show me the
remaining
correlation. Leg 3, every time you are getting one value now.
Oh, yes, sir.
Right. When I change the number, there is no the same increment. There is no same increment.
Yes,
when
sir.
there is no same increment, what exactly happening?
So correlation is different.
Earlier the correlation was high now when I use 1
yes,
leg.
Sir.
When I use 2 leg, then correlation goes down. 3 leg goes down. 4 leg goes down. 5 leg goes down. It's continuously goes down.
Okay.
Right.
Sir, if we can use data, high data, yeah, it means difference between the data is high. Then is it affected or not?
Actually, the concept of autocorrelation is when we are talking about either time series analysis or when we are talking about the, like this is the case of time series analysis, which I shown to you.
Sir.
Right.
Okay.
We have only sales now. We don't have any other variable.
Any other, yes, sir.
Right. When we have a single column, that means that data is coming from time to time.
Yes, sir.
It might be daily basis, it might be monthly, it might be quarterly, it might be yearly.
Yes.
That is what time series. When we have a 2 variable, variable X and variable Y, that is a case of regression.
Okay.
Right. In regression analysis, we calculate autocorrelation among what? Among residual.
Yes, sir.
Right. Have you heard the term that is Dorset-Watson test? Dorset-Watson test?
No, sir.
With the help of this test, we can test that there is an autocorrelation or not.
Okay.
It's going to tell us that there is an autocorrelation or not.
Not.
Right. Done? Clear?
Done, sir. Right, sir.
Anyone else? I'll tell you frankly. Can you, how many of you can put on your camera, please? I want to see your pretty faces. You all are very smart. Seriously. I am so dull person now. I'm so dull person. My voice is cracking. I'm not looking good.
Very impressive, sir.
No,
Your
no,
voice is
no,
very impressive.
no. Right.
Sir, knowledge is not need to face or your clothes, anybody.
Mahipalji, nobody is going to entertain if your face value is down. When you will enter in the room, na, who are you? Please move out. When you are looking smarter, please come inside and have seat. There is a correlation between the progress and face value.
Yes, sir.
Actually,
Definitely.
you will talk about the knowledge later now. When you will appear in interview, suppose you came for an interview in t-shirt and shorts. What happened? The principal, the director will say, please. Thank you very much.
Go back.
In fact, HR is not going to permit you.
Yes, sir.
Right. And when you are looking so smart, dashing like tie, white shirt and blue or black trouser and leather shoes with shining, what happened? Oh, very impressive person. Please come inside. Then only your knowledge will come. Right. Okay.
No, sir, nothing like that, sir. It is not like that, sir.
Now, if I'm talking about the autocorrelation, please try to understand. Actually, these topics are very tough. And I request you to, Ravi sir, please do FDP on these topics. Okay, we get the information related to such topic is rare. You will find many FDPs on this data analysis, many FDPs on Excel, SPSS and all. But if I'm talking about conceptual learning is important. And this time I'm going to discuss with you the concept which is behind the regression analysis. Although when you will study the regression analysis now, definitely you have heard about there must be linearity, there must be normality, there must be
Yes, sir.
must not be autocorrelation, there must be no multi-collinearity. Yeah, all the assumptions are there in the
Yes, sir.
right form. If I will ask, how will I check autocorrelation? How will I check multi-collinearity? How will I check linearity? How will I check heteroscedasticity or homoscedasticity? Nobody is talking about. Right. And when you will publish a research paper, what happened? There are so many times your research paper is dash rejection.
Yes, sir.
Dash rejection. Reason? Because of you develop a fantastic model, but you haven't tested these assumptions. And they can easily analyze it on the basis of R square, on the basis of VIF, and on the basis of other value. Yes, there is a collinearity, multi-collinearity, there is an autocorrelation, there is this. Oh, this model is not good. Reject. And when you will taking care of all these things, when you are writing research paper and your research paper is based on finance, your research paper is based on economics, and you are just developing a regression model and you are taking care of all these points and everything is clear, tick, 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 tick. I'm 100% sure your research paper will not be rejected. There must be a smile on your face now.
Yes, sir.
I'm going to give you assurance that your research paper should not be rejected by any peer-reviewed journal, if I'm talking about ABDC, if I'm talking about Scoopers, if I'm talking about Web of Science, SEI, no way, not at all.
Free journal, everything is.
Because of they analyze it very carefully.
Yes, sir.
And
Sir,
we don't have idea how they will analyze it. We were thinking, oh, my research paper is fantastic. It's looked like great. Just send it. And after 15 days, you will find a fantastic mail. Regret.
Yes, sir.
This time we are not going to publish your paper. Actually, your paper is not suitable to our journal.
Yes, sir.
And
Sir,
then we think, what's the problem with this paper? Everything is good. Oh, they were, that journal is not good. Editors are not good. We never realized what's the problem with it, right? That is why I'm discussing with it. Okay, now I'm going to discuss the autocorrelation with
Sir, I-
with residuals. Yes or no?
Yes,
It is
sir.
our requirement for forecasting. Just I'm sharing. Now, thank you very much. I've seen there are so many, genius person and scholars are fantastic. Seriously, thank you very much.
Sir, I have also used multiple regression in my PhD thesis.
Right.
Yes, they are, look at my screen.
I can see. I can see.
Yes, they're using a multiple regression in my PhD thesis.
So if you will see that your correlation linearity is good and value of R square is fantastic. Wonderful.
Sir, in all dependent and independent variable, R square is mostly more than 90 and 80, 88%, 80% up. Look at
And
this.
what about the ANOVA value of F? Just show me the value of significance of ANOVA. Now 0.04 good. It is less than 0.5. And the p-value of all, okay, 0.8 it is a problematic, yes or no?
Yes,
sir.
sir.
0.8
Yes,
is
sir.
also a problematic. You have to remove these two variables from your model.
Yes, sir. This is almost done, sir. My work, and I have on finding on my thesis.
We will discuss this later. I will finish this
Yes, sir.
autocorrelation first.
Definitely, sir. Yes, sir.
Right.
So I have a request
Fantastic.
for you.
Yeah.
Sir, please share your number after the workshop.
Definitely you will take my number from Ravi sir, right?
Yes, sir. So
Okay.
because of my thesis, I have some work.
Definitely we will discuss.
Yes, sir.
Right.
Thank you very much, sir.
Okay, now I'm talking about the autocorrelation. I will open one file. Just a minute. I will open one file. Now, this is what I just delete these matter. Then we will discuss the how we can check the autocorrelation, right? Please mute your mic, please. Okay. Delete. Okay. Now it's perfect fit. Good. Again, I'm going to do a regression. That is data analysis and a regression. Okay. And the first is what my sales. Oh. Control Shift up. This is what sales. If I'm talking about my independent variable, this is what my independent variable. And just labels output residual and click OK. This is what we got. Yes, everyone.
Yes, sir.
What
We
we
got
got?
ANOVA.
That is what regression
ANOVA.
analysis we got it, right?
Yes, sir. Regression analysis.
Regression analysis. And now I'm talking about the regression analysis. In case of regression analysis, because of I want to check the auto correlation among what? Residual, right? So these are the residuals now.
Yes,
Yes,
sir.
sir.
So what should I do? Control Z. I will take it on a new sheet, Anna, so that it's not going to disturb. Delete. And what I will repeat, analysis, regression, and the new sheet I will take and click OK. So I got the residual, and this time I will select the residual. Control C, pricing, and Control or V, the values. So we got the residual, right, everyone?
Right, sir.
Yes, sir.
Right. Now, what I'm going to do, I'm going to test it that there is a residual or there is a auto correlation or not. And there is one formula for it. That is what equals to and SUMMY SUM MY2 array is equals to, this is what my array 1 I select the data.
There is a noise behind. It is disturbing.
Please mute your mic, everyone. And if you have remember, I leave the last value, yes or no?
It's a leg one.
Yeah, it's a leg 1. And this time I'm going to select from the last, but I will leave the first value, right?
Yes, sir.
And divided by, that is what, sum square of all values. That means the entire value. Done. And just entered. Got it my point?
Sir, pardon, please repeat it.
What I did, I just used this function sum x my my2, right?
Yes, sir.
I will repeat it again. I will just delete it.
No, sir. Okay.
Equals to sum x my2. Yes or no?
Yes, sir.
And what I'll do, I'm just going to leave the first value, right?
Yes, sir.
And I'm going to select the entire,
Reduce, sir.
I have to select the residual, right?
Reduce residual.
This, right? Then put comma. And this time I will select from the second last value, right? Up to first value.
Yes.
Okay.
That means in first time I'll leave the first value and the
Yes,
second first value to second last value, then second value to the last value. That means there is a one leg of 1. Clear?
Yes, sir.
Now divided by sum square. Divided by sum square.
Sum
And
square.
select select the all values, all residual, right? And just entered. Agreed?
Yes, sir.
Okay. What about the lag? 1?
2 point.
Our lag is 1 now?
Yes, sir.
Lag is 1. If I'm talking about how many lag we use?
1.
1.
2 and 3. Yeah.
No, this time I use lag
This,
1 only.
yeah. Yes, sir.
Right. And what about the alpha? That means significance level.
0.5.
And what about the
0.05.
sample size? What about the sample size?
Sample.
That is 200.
Yes, sir. Huh.
200.
200. Yes, sir. 200.
Okay. Now you will see the value of the table. Oh, we have up to 29 only. Can you see this table?
Yes, sir.
Yes.
Word document?
Yes, sir.
Right. Can you see alpha is equals to 0.05?
Yes, sir.
Yes, sir.
And there is a k is equals to 1, k is equals to 2. This is what lag.
Lag.
Right. And this is what sample size. But what about our sample size?
Sample
too
size
large,
is 200.
200. And
Yes,
I
sir.
have table up to 29. Can we do one thing? Can we reduce the data?
Yes, sir.
And for calculation
Sure.
purpose, we will take only in a table,
50.
how many?
24.
We
25.
can take 25. Yes or no?
Yes, sir.
We can take 25. Just a minute. I'll do it. I'll take 25, Control C and Control V. Can we do it again?
Sir, it's
Yes, sir.
just assumption or
No. It is not just assumption. Because of the limitation, I don't have the entire table now.
yes, sir.
That is why I took the only 25 sample, right?
Okay.
Now, regression. I just delete this thing. And if I'm talking about y, this is what my y. If I'm talking about x, this is what my x. And this, everything is done. Our new worksheet. Okay, click OK. I got the residual. What I'll do, can I do copy?
Yes, sir.
And paste it here. Only values. I got the residual. Now what should we do? Equals to
Some
X,
my
X, Y.
this is what? First to second last, comma, last to second. That is lag is 1 now.
Yes, sir.
Yes, sir.
Divided by
Sum square.
sum square. Take all the values
All the values.
and just entered. What is the value?
2.12.
2.12. Right. And can you tell me what is the value of k? K means lag.
1.
1.
1. And what about the alpha?
Sample size. Alpha is 0.05.
0.05.
Yes, sir.
0.05. What about the sample?
25.
25. Can we see
Yes,
the
sir.
value? 25. There's 1.29 to 1.45.
Yes, sir.
Yes, sir.
1.29 to 1.45.
25.
So
45. Yes, sir.
you just come. Oh, where is my table? This. So what about lower limit? 1.29.
1.29.
And what about the upper limit?
1.45.
1.45.
1.45. And what is your value?
2.12.
2.12. Your value is not come between these two values now.
Yes, sir.
Yes, sir.
What is going to show me? There is a autocorrelation, yes or no?
Yes, sir.
High, sir.
There is a
Autocorrelation.
autocorrelation. It is clear?
Yes, sir.
Okay, let me check. Can we check it?
But sir, it is not coming under the limits.
What I'm going to say, just where's my pen? My pen is missing. Oh, I got it. What is your lower limit?
1.29.
What is your upper limit?
1.45.
1.45. If your value comes between this, accept null hypothesis, yes or no?
Yes, sir.
If this value is lower than this value or higher than this value, what you will do?
Reject the null.
Reject null hypothesis and
Except alternative.
reject null hypothesis. That means accept
Alternative.
Alternative hypothesis.
Alternate hypothesis.
right. What is your null hypothesis in this case? There is
State is not dependent on the variable.
there is no auto correlation. There is no auto correlation among the residual. Yes or no? There is no auto correlation among the residual when your value come between 1.29 to 1.45. Yes or no?
Yes, sir.
Or if your value comes above to the 1.45 or below to the 1.29, that means there is
Reject the hypothesis.
auto correlation among the residual. Agreed or not?
Yes, I got it.
Just tell me what we did. We find that there is a auto correlation not among the this. Agreed or not? Is it clear or not? Please tell me.
The auto correlation is doing.
Yeah, auto correlation is there. It's going to show me that auto correlation is there. Yes or no?
Yes, sir, there is a higher autocorrelation.
Yeah.
There is high autocorrelation. 2.1.
Right. There is a auto correlation. We can't say that there is a high correlation or low correlation, but there is a auto correlation among the residual, right? So
Sir,
these are some points which you have to remember. Yes, please.
Sir, can we sort out the for my means is that we are increase the lag, then we are autocorrected with less or not?
When you are going to increase the lag,
Yes,
your
sir.
auto correlation is going down. If I'll take in the same example, I'm going to take lag 3. Yes or no?
Yes, sir.
Instead of this, what I'm going to take? Lag of 3. So this is what F2 to 25. Instead of 25, can I take this? What 23? Right? And 1, 2, 3. That is what 5. 5 to 26. Right. Just enter. What is the value of it?
1.73.
73.
When lag is what? 3.
3.
ठीक है ना? Now we have to check. Now we have to check the value again. Now we have to check the value again. You just check the value. Lag is 3. And N is what? 25. What is the value? 1.2 to 1.16 now? 1.12 to 1.16. Yes or no?
Yes, sir.
Yes, sir.
Where 25 is the upper limit and lower limit. Got it? And what exactly is our value?
1.73.
1.73. So if I'll see that is 12 and 66. 12 and 66. So this is what lower limit is 1.12 and this is what 1.66 and your calculated value is slightly above the this. Yes or no? Even
Yes, sir.
there is a auto correlation.
Yeah.
If you will increase the lag again, might be your auto correlation is removed.
Yes, sir.
Right. But in general science, we will take a lag of only 1. And normally what we will do, we will use the lag of 1. Right. Now, there is one important thing to you all.
Sir, excuse me, sir. I have one
Yeah.
question. Sir, if we want to decrease autocorrelation in lag of 1, what we can to do, sir? To
No, you
improve.
can't do anything because of you are not supposed to do manipulate the data, na?
Sir, we can increase the time series maybe?
No, it doesn't matter. If you have remember when I was taking the entire 200 data, the value was again 2 point something. Have you remember?
Yes, sir. Yes, sir.
When I took only to a data of 25, again the value is almost same, 2 point something. Look at here. Just come back. Just come back. Undo. What is the value of this? We use only one lag na. You can see the difference between color. Is it visible? My screen?
Yes, sir.
Not, sir.
Now? Just tell me my screen is visible or not.
Yes, sir. Now it is visible.
Right. What is the value of this auto correlation test? 2.12?
Yes.
2.12 when? When we are using lag of 1. Yes or no?
1 and the sample is 25.
No. Sample is 25 and lag is 1. Lag
Yes,
is
sir.
1 na?
Yes, sir.
You just focus. There is a difference between the color red and blue. You just
Yes,
see the
sir.
color at this 2 place where I am going to make an arrow. You just see. This is what? From 2 to 25 and 3 to 26. That is means lag is 1. Done?
Yes, sir. Yes, sir.
Okay. And my sample size is 25. If I'm talking about in this case, when my sample is what? 200. What is the lag? What is the value of this? 2.08 now?
Yes, sir.
Now this is what? 2.08 and this is what? 2.12. Is there any difference? Major difference? 2.08 and 2.12. 2.12. And sample size is what? 25. And sample size is what? 200. It doesn't matter now.
Yes, sir. Sample doesn't matter.
Right. One of my family doctor asked me, you just do a sugar test. He took a sample and only one drop. If you have seen the glucometer, electronic glucometer, they just prick your finger and take a one drop of blood, which soaks by that SIM, right? That chip. And what happened? My sugar was 160. And doctor asked me, yes, it's very dangerous. You have a sugar. Mega, no, you just took a one drop now, a small sample. You just take 100 ml blood. Then you will test it. You will find there is no sugar.
Yes,
come
sir.
on. Am I right
It
or
will
wrong?
be same, sir. It will be same.
It doesn't matter the sample size is 225 or 200 or 500. If your sample is random, although if you are working with 25 sample, you can manipulate the 25 data. Yes or no? For every value, you can test the that value. Yes or no? But it is possible for that you can manage the entire assumption that there must be linearity, there must be no autocorrelation, there must be no collinearity, there must be a normality, there must be a homoscedasticity. Is it possible here that you can balance each and every assumption of your data
No,
by
sir, no.
manipulating data? Completely impossible. And definitely you will find some problems. And I will discuss it on last day. If you will face some challenges, either one or two assumption, what should you do? Definitely I'm going to help you out. Yes or no? Suppose I found that each and everything is fantastic, but I found that there is an autocorrelation in my data, in my residual. That means model is scrap. This model is not working. I will suggest you what should you do. Yes or no?
Yes, yes, sir.
Yes, sir.
But at the end, picture abhi baki hai, right?
Right, sir.
Okay. So any doubt up to this point, please, because of it is very difficult for me to speak continuously. Now I'm facing some problem. Yes, any doubt, please ask me.
No, sir. Up to this point, it is clear.
Okay. Anybody tell me in brief that what we learned in last 4 days? Yes.
Sir, on first day, we learn about the basics of
Okay.
research,
Yeah.
the types of research. We were discussing about the descriptive research and how we describe the data.
Right.
The second day, we were doing the regression.
Right.
Linear regression and multiple regression also.
Third, we have done the homoscedasticity and heteroscedasticity. And
Right.
today we are autocorrelation.
That means all assumptions are covered. Now thing is that what is the difference between regression and time series? What is the difference between regression and time series?
In which sense, sir?
In the like how you will identify that this data is time series data and this data is regression. If you have remember in the regression, we have a dependent variable and independent variable.
Yes, sir.
Sir,
There was.
Right. But in
Time
case of a time series only, we have a single column.
Yes, sir.
And independent data is basically a time.
Yes, sir.
Independent data is basically what? Time.
And
When my value is depend on time, that is called time series analysis. I'm just telling you, I will share my Word document. Actually, it is very essential. This time I'm going to delete it. I don't want to open new file, and you just look at here. Suppose I have two series, series X and series Y. This is what my expenses, and this is what my income. Can you tell me, can you predict the expenditure on the basis of income? Definitely, that you will say expenditure is equals to A plus B multiplied by income, right?
Yes, sir.
This
Yes,
is
sir.
what a regression. This is what regression. If I'm saying that my sales is this. This is what my sales like 2011, 2012, 13, 14, and this is what 20, 21, and now I'm talking about 22. I want to know what will be the expected sale in the year of 2020. What exactly it is? Definitely you will say that it is also a regression. Yes or no? Because of your, what is your independent variable? That is what? Time.
Yes, sir.
And dependent variable is what? Sales.
Sales.
You can say that sales is equals to A plus B into time. Right. But can you think so that you can always use a regression, simple linear regression in case of a time series analysis?
No, sir.
Why no?
Because, sir, in spite of time, there are more variables which are affecting the sales.
But suppose you have only sales, you don't have any other data. If I'm talking about price of a petrol in last 10 years, I'm going to calculate average pricing monthly basis of last say 2 years. That is what January 2020, February 2020, March 2020 up to December 2021, complete 2 years. And I have a price, I have a data like price, average pricing of that month. Can you predict the average price for the month of August, September, October?
Yes, sir.
How you will predict? On the basis of regression?
Now, on the, sir, we can also calculate the growth rate and we can add that into the basic calculation.
Okay. That means you are going to, involve new concept, that is what growth, right?
As we do in the cost of capital.
Okay. That means
In
on the basis
calculating.
of growth, you want to predict the future.
Yes,
Agreed.
sir.
Agreed. Some
Sir,
other
every time,
method? Some other
so
method?
growth value is not perfect every time.
When I'm said that you are perfectly said, that's why I'm saying any other method.
Natural logarithm.
Okay, can we talk about the price of mango in last 10 years? Price of mango. Can we talk about price of any other commodity in last 10 years?
Yes,
You
sir.
might have heard, if I'm talking about the wheat, if I'm talking about the bajra, if I'm talking about other grain, what happened? The price is fluctuating now.
Yes, sir.
Yes, sir.
In season, price came down. In off-season, price may increase. Yes or no?
Yes, sir.
Yes, sir.
And vice versa, in season, price increase. Like at the time of festival, price of some commodity
Yes, sir.
increase, and off-season price goes down. Yes or no? So it's totally depend commodity to commodity. So, we can analyze such product. If we talk about the price, basically time series analysis is more related to finance as well as economics. Yes or no?
Yes, sir.
So tomorrow we will
Actually,
discuss about the time series analysis. What exactly is time series analysis? How many different types of time series and how we will analyze? Might be you have heard few time series method, that is what trained.
yes, sir. Trend
Seasonal,
analysis. Yes, sir.
seasonal.
Yes. Yes, sir.
Yes, sir.
Yes, sir.
Yes or no?
Yes,
Yes, sir.
So what exactly is seasonal time series?
So on a particular interval, the price fluctuates.
On the basis of particular time frame, time gap, your price is fluctuating. Yes or no?
Yes, sir.
The
Yes, sir.
price of AC, the price of refrigerator is increased in the month of April, May, June, and July.
In summers, yes, sir.
Right? In summers, price of AC and refrigerator is increased, ceiling fan and cooler and all. But in the season of winter, price goes down.
Yes, sir.
You will find a discount. You will find a scheme. So this is what this is what seasonal. And there are so many products. If I'm talking about petrol price and diesel price, if I'm talking about electricity price, is there any seasonal effect on electricity price, petrol price?
Never, sir.
No. There are some other factors which are going to affect it. Yes or no? So the price of petrol, diesel, and gas and all, it is not depend on what seasonal. So the trained method is not seasonal in case of these products. So we have to understand our data, that what kind of data we are going to deal. It is a seasonal, it is a trend line, and if it is a trend line, what kind of trend line it is, right? So we will discuss it tomorrow. So our upcoming 3 lectures is totally based on what? Time series analysis. Is it clear to everyone? Any doubt you can ask?
So then forecasting will be done in the time series analysis.
Yeah, forecasting is also possible in time series analysis, but it is a little bit complicated, right? Where we are going to give you a range between this to this. Ki might be your highest sale is this, lowest sale is this. Yes or no?
Yes, sir.
But in case of a regression, we are just going to give the particular value. Because
Got it,
we
sir.
are going to draw a line now. It might be a straight line, it might be exponential. We are not going to give a range.
Yes, exactly.
Right? Yes. Anyone else?
Sir, Durbin Watson is there in Excel, sir?
Yeah, which method I told you, na?
Yes, sir.
To find the coefficient of, so to find the auto regression in your residual, that is what Durbin Watson.
Okay, okay. Thank you, sir. Yes, sir.
And this method is so simple, na? It is not complicated.
Yes, sir.
Yeah. So I think there is no doubt. Yes, Ravi
Yes,
sir.
sir. Till
Yeah, yes, ma'am.
Thanks a lot, sir.
Ravi sir. Aarti ma'am.
Yes, sir. Yes, sir.
Sir, excuse me, sir.
Yeah.
Ma'am, sir, excuse me, sir. If there is any assignment for the topics that you have delivered, it will be better for us to explore ourselves, sir.
I will share my data with you. Don't worry.
So preferably if assignment, if you have given me, so that will be better, sir.
Why only you?
For
I can
others
give the
also.
assignment to each and every person.
Everyone.
We can make it mandatory that everybody is going to make everybody is going to make a regression model, and they will test each and everything.
Yeah, certainly, sir. It would be better, sir. It would be better, sir.
You just prepare the, might be you will got a threatening call. Why you suggest such assignments to the sir in the presence of Aarti ma'am and Ravi sir especially. Okay, I will send my assignment to Ravi sir, and Ravi sir is going to circulate it.
Definitely, we will share with you. If sir will share with us, we will definitely share. If we think that it is needed, then we will definitely share.
For practice purpose, it is required.
Sir, we will send.
Yeah,
no problem.
I will share my data with you, and they will develop a model on that data.
I will share with them.
Yeah.
Any questions to Dr. Vijay sir? Because I think sir needs some rest also. He needs some throat rest. So, Aarti ma'am.
Sir, Dr. Brijesh Avasti, sir, we are really, really grateful to you. You are commendable, sir. Honestly, you are par excellence, because I have also attended so many workshops and FDPs, but so much of active participation from the participants that clearly shows that such a bond you have developed with them. And sir, you also know it is very difficult to maintain a bond with a resource person who is coming to teach you for a week or so, but such a beautiful bond you have developed with the candidates, and even the candidates are very, very active. I must congratulate them. I must tell that all the candidates here are also very, very, so many videos were on. Otherwise, most of the times what they do, they just participate for the certificate and they do not attend actively, but all the candidates are also participating actively. And sir, irrespective of your poor health, then also you are taking the lectures continuously, on time. You're not delaying it. That's really commendable, sir. And in a week-long FDP and workshop on time series analysis, this was the end of 4th day, where the topic was probability models for time series. I am sure all the candidates must have learned in a brilliant way, and all the problems they have, you solve them so nicely. And sir, this is very rare that the participant is asking for homework or assignments. So that shows that so much of interest you have created in them. So congratulations, Professor Brijesh Avasti, sir, for being such a wonderful teacher. And we are really thankful to you on behalf of Inspira Research Association and Chandragupta Institute. Thank you so much,
Thank
sir.
you, ma'am. Thanks a lot.
Thank you. Thank you so much, all of you, once again. Thank you, Brijesh sir. And please
Thank you, sir.
take care,
Thanks a
sir.
lot.
Take care of your health.
Yes, sir.
Please take care of your health, sir. We
Tomorrow
need you.
we will meet. Yes. Tomorrow we will meet same time on the topic day 5, estimating the autocorrelation function and